Hello and welcome everyone to the Security, Observability, and Network Traffic Management for your Cloud Native Apps webcast. My name is Tara Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today we're excited to show you how the OCI Service Mesh simplifies the development and deployment of Cloud Native apps. If you do not currently have an Oracle Cloud account, we have placed a free account link, including a special promo in both the Zoom chat and the Slack channel. I'll post these links again shortly for anyone that is just joining. We'll be recording today's session, and after the webcast concludes, you'll receive the link via email. If you have any questions during the webcast, please ask them in the Slack channel and we'll answer them throughout the session. The link to join is bit.ly/devrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for webcast-service-mesh to reach our dedicated space for Q&A today. And special thanks to Abhinav Mishra, who will be helping answer questions. Today's webcast will be presented by Dusko Vukmanovic, Senior Principal Product Manager of Cloud Native Developer Services. So without further ado, I will hand it over to Dusko.
Thank you, Tara, for this introduction. Let me share the screen. So hello, everyone from my side. I'm Duško Vukmanovic. I'm the Product Manager for the Service Mesh. And together with me is my colleague Abhinav. He's architect. So you can use either that Slack workspace and that channel specific for this session, or you can also use a Q&A feature of the Zoom, and you can post questions there during the session. Now, we should have like 10 to 15 minutes at the end for the live questions, but anytime during the session, if you have something to ask, feel free to use those options. So let me then present what is the OCI Service Mesh, and at first, how it can help you so that you can gain productivity while building the cloud native app if you are using such a product. So this is the agenda. I will first set a context, like why we need a service mesh. I will not go that much into those kind of detail. I'm assuming, since this is for developers, let's say that you already have some needs for that. But then I'll talk like what is the OCI Service Mesh, how we did implement it, what are the benefits that you can gain, and then the majority will be like actually what is the architecture, how you can use it, and then the demo that shows you those benefits that you can gain. I think this is not something that is not known to you, but like majority of customers today are using microservice architecture, cloud native apps, containers, Kubernetes, in order to build systems, and then they can respond quickly based on the customer needs or to competitive threats. So in the center of everything are cloud native application. But then how you build a cloud native application, you build microservices. And then the way how you connect them actually is how you produce and deliver your cloud native application. And so those are here. You can see those characteristics of the cloud native application. But I think for us, for today, I think important thing is that you can have, now you can imagine, now you can have a different teams who are building those different microservices. They can be built by using different languages and different frameworks. And now, but each microservice has infrastructure requirements, like it has to be secure, you have to be able to monitor it, and you want to dynamically configure how they communicate. So this is the needs that we have as a developers. So this is our goal: how to ensure those infrastructure requirements, but not to build code for that. And if you don't use Service Mesh, for example, then you can use different libraries specific for your languages. But then you have to maintain this, and it's very hard to have a consistent pattern for all those infrastructure needs across the different languages, and most importantly across the different teams. So now, therefore, there is Service Mesh, which enables you to actually, if you add extra, you get extra layers. So you have like infrastructure layer, and then you have like Kubernetes, which is orchestration, and then you have application. Now between the application and Kubernetes, now we are adding this mesh layer, which is, well, application infrastructure layer, and then you can get those features, security monitoring and connectivity, by just configuring the mesh. So you don't have to build the code for that, and then you don't have to maintain that. So it's really boost your productivity. And from my perspective, this is like number one reason why I would use mesh. Like it's really increased developer productivity. How? Well, providing you those security features that you need, visibility, and again, the way how you can manage the traffic. There is another important thing, which is actually regarding operational efficiency, because if you remember from the beginning, we mentioned like, yeah, everybody's building cloud native application because like they're promising business agility. But if you don't have like for example, without mesh, now imagine you build your cloud native application. Now you have to cut the ticket to the service team or the network team to set up the network. So it's a really not agile. So now with Service Mesh, again, you have like central place where you can manage your access policies, and then you can define which, how services can communicate. And again, from the central place, and finally, this is something that application team can do without like involving external team. So this is how we built our service. You can notice here the proxy component. Our proxy component is based on Envoy. It's a CNCF based open source component. And we inject this proxy in front of your services. Now, when we have this proxy component in front, now we can control any traffic that goes in or goes out. And this is how we actually, control the application and behavior of application. The second part is the control plane, which is for you as a user is like a central console where you go there and using OCI mesh resources and we will talk about that, like mesh, virtual service, virtual deployment. Now you are shaping your application, and then you are using different feature. And actually, even though we are using proxy behind, you are not dealing with the Envoy setup or configuration. We are translating this for you and pushing into the proxies. So this is how you manage your application from the central place. Now, on the right side, you see the list of features that we are supporting now at the GA time. And they are like in order by like priorities based on my discussion with internal and external customers. So number one reason is security. It's about how you encrypt the traffic and how you authenticate your microservices and access control. And then it's how you monitor, not like just one microservice, but like end to end, and then how you manage the traffic among the microservices. Today we support OKE platform, and you see the list here of the communication protocols that we support today. So who can benefit from the OCI Service Mesh? Well, obviously you have some hints here on the slide, but have in mind like that OCI Service Mesh is a free service and it's managed by OCI. And this is on the one hand. On the other hand, many businesses, regardless of the size today, they are requiring security. So typically, if you are the bigger organization, you may have more benefits. But again, it's a free service. It's managed by us, and most of businesses today require security. So even if you're a small organization, you can have benefits from the OCI Service Mesh. So let me now go through the features that you get out of the box. First one is security. And actually, I will show later how you set up the security as the part of the enablement. So when you want to use mesh, you have to enable it on your Kubernetes cluster. In that process of enablement, actually, you provide necessary details, and And actually, security is by default on. There is no specific configuration steps after that. And the major things here is actually something that we call MTLS. MTLS is like a form of transport security that provides but this is important, it provides confidentiality and authentication of microservices, of communication itself. So not only that communication is encrypted, but the identity is validated on both sides. So therefore we call this mutual MTLS. So this is like different. For example, when you communicate from your browser to some website, it's just one TLS because your browser is just validating, is this really the site that you are connecting to? But usually website doesn't care who you really are. But this is important because usually there is always like emphasis on encryption, but validation is very much important because if you know if you get a encrypted message but from the bad actor, this is like not a good thing. And we actually authenticating your microservices using virtual service. This is mesh resource. All right. And yeah, so essentially the only setup you do is you provide certificate authority in the moment when you create the mesh. And for that, you can use OCI certificates and you define your private key. And after that, you are good to go with security. The next thing is observability. So we provide a set of metrics. And then we also, but for metrics, we provide Prometheus integration. So you will need Prometheus in order to consume the metrics. And for the logging, we provide integration with OCI logging. And I'm not talking here about the logging that comes from your application, but this is something that we call access logging. So again, remember, we know any traffic that goes in, goes out from your microservices, and then any request. So we log this, and we call this access logging. Now, regarding metrics itself, there are two kinds. One is integrated with OCI monitoring, and this will help you that you can see how many proxies you're running. But through Prometheus, you will be able to fetch any metric that Envoy provides, and there is like hundreds of metrics. I listed some of here that you can see just for example, but there is a huge number of metrics, and then you have to pick and choose what do you want to use. And there are default dimensions are here, are mesh, virtual service, and service version. Regarding traffic management, yeah, we can, you can split the traffic. So you can support multiple versions for your microservices, and then you can split the traffic between them. And we call, and then you actually define like the percentage of traffic that you want to for every version of your microservice. And having this in place, you can do counter deployment. So you can, when you deploy the new version, you can slowly increase the percentage of traffic that goes to the new version. And when you gain confidence, you can like either fully switch to the new version. But at any time, if there's some issue, you can just revert back, and then you have your previous version, which is working. And we also provide you ingress traffic control. So it's a kind of ingress gateway, but just like with more options, and it provides you the so you can actually, so this is how you will expose your application to the external clients. And you don't want to, for any service that you want to expose, you don't want to have a load balancer for that. So therefore you can use ingress gateway to specify path name or host name based routes, and this is what microservice should respond based on requests that come in through the load balancer through the ingress gateway. Now this is like that was like a little bit about like what you can expect for the OCI Service Mesh. Now, let me now walk you through the example of one very simple Kubernetes application, and then see where in this picture, how the mesh resources fits into this picture. So this is super simple application, Service A, Service B, and it's exposed using Kubernetes load balancer, which in the cloud, when you use a cloud vendor like OCI, when you create this Kubernetes service type load balancer, it will create external load balancer for you. So this is how your customer will access your application. So either to deploy your application using like pure Kubernetes, you are already using Kubernetes abstractions like services. Otherwise, it will be super hard to create the Kubernetes application, because you will have to hard code, calling when from the service A, but when you call service B, you would have to hard code this call. But having this abstraction layer that Kubernetes provides you makes it easier for you to write this application. Now, have in mind that those lines with arrows are just logical flow, but always the real communication is happening among the pods. But this is just how pods are figured out. Okay, where is the next pod that I have to talk to? Well, they figure it out through those Kubernetes abstraction layer, but it has many constraints. Now we are introducing the mesh. First, we create the mesh resource. It's just a logical boundaries where you would create all your other resources. Now, and then you create virtual service, which is exactly like your microservice that you are maintaining in your application. And then for each version of your microservice, you create something that we call virtual deployment. And this line here represents command that you run with kubectl, and we call this binding. When you run this binding command, so this is the moment when we inject the proxies into your pod, and from that moment we are controlling the application behavior. So essentially, this binding is like associating the set of pods that represent that specific version of your microservice with our virtual deployment. Now, when you have this in place, you can use virtual service route table to manage the traffic if you want. If you want, let's say, uniform distribution, you don't even have to use the virtual service route table, for example. And then the way how you expose to the external customers is using Ingress Gateway. Now, notice here that the blue parts are a part of Kubernetes deployment, and essentially we don't touch it, but then green parts are mesh resources that we are introducing. And then the last thing is access policies. So by default, when you set up the mesh, microservices cannot communicate it to each other, but you have to explicitly create access policies, and then you have to say, oh, they can communicate with each other. And yeah, so this is like for your one service. Now notice here that again, we have a picture of this Kubernetes service load balancer because we had it at the beginning. But if you don't want it, like, you can use Ingress Gateway, and Ingress Gateway can provision for you LBAS. But if you have already in place, then we can keep it. And now, when we come back to our example at the beginning, now we have this full. So this is meshified your application. Again, green parts are mesh resources, and blue parts are the Kubernetes. Again, lines with arrows, a logical flow, real communication is happening between the pods, but now pods are using the mesh layer to figure it out how they have to communicate between each other. So when you have like line of code, so this is service A, and then if you have like line of code that is calling service B, and now because we have proxy, we intercept this, and then using our mesh resources and settings that you set up, at the end, we decide that does this call ends up here or it will ends up here, for example. Now I will show you the demo. I will show you, how you can use, what you get from the Service Mesh. I will use this application. This is Pet Rescue demo application. There's like 4 microservices, like UI, pets, breeds, different breeds, cats and dogs. And then notice that this pets microservice has a 2 version, V1, V2. V2 is obviously will return more details because it calls this pet details service microservice. Now, before jump into the demo, let me just give you attention that like we are supporting 2 kind of experience. One is the pure OCI experience or native OCI experience, which is like where you are using OCI console or using OCI API, Terraform, CLI, and then second experiencing using kubectl experience. So today here I'm using kubectl experience because I'm managing anyway my Kubernetes with kubectl. So I want to then also use the kubectl also to manage the mesh resources. Have in mind just that when you pick one of the options, then you have to stick to this option, and this is because how Kubernetes works. And just for you to be aware, so because I will use the kubectl experience, so that means that anything that is relating to mesh setup, I have to prepare as a YAML file. And now you can have a question, okay, where did I get those YAML file? Well, I took it from the documentation because for each resource there is an example. And then you just update those example based on your data. For example, this is the mesh resource, this is the namespace, this is the compartment, this is the certificate authority. Here is the virtual service, for example. This is my default routing policy. So if I do not define routing table, it will be like 50-50, for example. This is my virtual deployment. And essentially, when you create these things, at least when you create your YAML file, at least for the first resource, and next is just like copy paste, and then you just change some things, those things that are coming from the Kubernetes. So, well, this is my attempt to just I'm trying to help you to have in mind, like when you create those mesh resources. Well, in that YAML file, there are some things that are related to the mesh itself, and then there are some things that are referencing your Kubernetes application. So in the virtual service, we have this host, but this coming from this Kubernetes service. In the virtual deployment, we have host name. Yeah, that comes from this service that is specific for your version, and then in binding, we are referencing specific version of your service. So, for example, this is virtual service, how you create this. Again, you just go to doc and copy paste, and then you pick up this part now this is part that it will be different because this depends on your Kubernetes application. So this name here comes from like Kubernetes service name, and ports are those that are exposed to the deployment. Of course, you will have different compartment ID, but again, maybe you will have a different namespace. But the important part is this that comes from the Kubernetes application. And then for the virtual deployment, same thing. This is part that comes. So those are touching point with your Kubernetes application. And this is third touching point. This is virtual deployment binding. So we are, again, connecting virtual deployment with a set of pods that represent your specific version of the microservice. And then this is the moment when we inject the proxy. Yeah, so I will now switch to the demo. Yeah, so this is my demo application. You have like a different breeds, and then I pick one. For example, I get some details. This is like a lot of details. So this is obviously V2, but if I, let's say, refresh couple of times, I should get V1. Now this is V1. Now, in order to present you some useful data, I'm having load simulator running behind. So this is the reason why, because even though I have like 50-50 split, why I didn't get it second version on the next refresh. So this is my application, and this is the console. Yeah, I'll come back to console. So let's start from the beginning. So first of all, I created my application that I show you here. So so this is my application, and this is how I create. I just run my Kubernetes YAML file, and this is nothing special here. This is just a typical Kubernetes manifest YAML file that I run, and I can show you all the services that we have there, and those are microservices that I show you, like UI, breeds, pets details. Yeah, and okay, I have load simulator because those are some helper pods that help me because of the demo. Now, the next thing, I put the label of the namespace where I want to meshify my application. I already run this command, and after that, I just run my meshify YAML file, which is actually I showed you. So this is like all mesh resources. Like, so this is the mesh definition. This is a virtual service. So for each your microservice, I have virtual service. For each version, I have deployment, and so on and so on. And then also I have access policies at the end. So for example, you can see here that anybody can talk to UI, for example. So no, UI can talk to the breeds. But interesting that only the ingress gateway can talk to UI. So this is the only, actually, so the only UI is the only microservice that is exposed to the external clients. And then I run this file. And then I explained you how I did actually, how I get this. I, again, copy paste from the docs and then update based on my environment here. And once when you create those mesh resources, you can check the status. I'm checking the mesh status and looks good. And the final thing, so now, so where we are now, so we started at a Kubernetes application. We put the label to the namespace. We created the mesh resources that we need, but we still don't have proxies. Now we run this binding command. And this is binding command. Again, this is the moment when we inject in the proxies and we are connecting virtual deployment with a set of pods that are specific to this particular version of your microservice. Now, after that, I can show you the list of pods. And you can see actually that like 2 × 2 means like together with your business container, there is also our proxy container. And just as an example, let me check the UI pod. So you see in your pod, there are 2 containers, UI, business, business logic, and this is our proxy container here. So now at this moment, now we are good to go. So we have mesh which is up and running, and we can start using the mesh features. Now, security, because actually you don't have to do anything about security. This is, security is done as soon as you enable the mesh, you already have security. So therefore, if I go to the Service Mesh, and by the way, so we are using OSOC, and OSOC is the way how we synchronize those resources that you are creating using Kubernetes kubectl with our control plane. And this is the reason why you can see it on the console. So OSOC is open source Kubernetes add-on that comes from OCI, and allows users to manage OCI resource. So there is like operator for MySQL, Mesh, and some other OCI services. And this is all based on Kubernetes operator. And this is like this is how you package, deploy, and manage Kubernetes native application. So you have like set of custom definition resources, and then you have control, which manages your resources. All right, so I'm going to show you, so how the mesh looks like from the console. Again, you can see here these virtual services that we created. Here you can see, for example, pets. They have 2 versions. I can see the root table. I can see that, for example, currently the traffic is splitted. I should be like 50-50. Yeah. So, but I wanted to show something. In order to set up mesh, I need first create this certificate authority. So you go here on the OCI console, you are using OCI certificate service, and then you create your certificate authority. And this is like the only things that you need to that you have to do regarding the security. Now, when you create your CA, well, in this process of creating CA, you will be asked for private key. You will create your private key using OCI Vault, and that's it. After that, we will use this CA when you. And now we will use CA together with key, and then we will create all leaf certificates. Now I can pick one of those certificates, and if I check the subject information, I can see something, and this is like part of the OCID of the virtual service. So this is how you can see that really certificates are generated and your microservices are using it. Now, another way how I can show you this is if I run this command. So this command, I'm using my test pod where I have OpenSSL utility running in that pod. So I'm using OpenSSL as client command to connect to UI, and then I am insisting on the MTLS. So meaning, it should be like a mutual TLS, no one way. It's like 2-way. Now, because OpenSSL is not under the mesh control, it didn't get this certificate. So this command cannot work. And this is why we got this response. But I can show you a response from the UI side, because in this command, OpenSSL is client and UI is like a server. So you see that certificate that is coming from the server side is this one. This is this common name that we'll check on the console. And this one, this is like our CA. And you see that what is coming. So now you can see that microservice, which is under the mesh control, they are using certificates, and they encrypt communication, and they want to authenticate. And then you can also see what kind of client certificates you would have to have in order to talk to the microservice that is under the mesh control. So somehow I'm just, again, and security is on by default. I'm just kind of giving you a proof about that. So the next thing that that you can get from the mesh is like, when I was showing you this, in some moment, there is some like latency. Now it's very hard to find where is this latency, but if we have, let's say, this Grafana dashboard, and then this is my UI service, this is my pet service. So for each my service, I have dashboard. I can see actually that on the UI, it's a pretty big latency, like 1 second. This is a lot. Now on my pets, I see I have 2 versions. V1 looks good, but V2, so looks like V2 is bringing this latency, and then I see like, well, how the traffic is split. So it's like 50-50. There could be like up to 5% plus minus, given this setup that is 50-50. So now, once having you in this in place, you can really quickly spot like, well, where is the problem, and then developers can fix this. Let's say that we are deploying now a version which is now fixed. Well, we are just redeploying a pods, which is now fixed. And then also while we are doing this, let me change the split the traffic. So, because again, I'm using kubectl experience. So this script, this YAML file here will actually will say that the new version of my service, give it just 10% of the traffic, and then existing one, just give like 90, because we already have issues with V2 in the past. Now we don't want to give too much traffic at the beginning to this service. And then over time, you can change this split. Now, next thing is about the logging. So for example, if I check the logs that, for example, I can get from my application, it's really not much, but again, whatever it is there, it really depends. It's a part of the business logic. It really depends on developers, well, what they will put there. But with access logs that we provide by default, you can have really extensive logging. So let me create some error, for example. So I'm just scaling down one of my services to 0. And then essentially I'm causing like a response code 503. And because this is 0, what else? Yeah, so because this is 0, my application, well, it can't work. Yeah, it again does not work. Sometimes, yeah, maybe you see, for example, again the UI behaves strange. But those guys now looks good. You see that over time they are now splitting to 1090. Yeah, they need a little bit more time, but they are now look good. So somehow, sometimes metrics does not always help us. So let me go to the logging then. Now I go to the logging, to the logs, and then the only thing that you have to set up is this agent configuration. And again, this is all documented, but you see here. So from that specific namespace, I'm taking my proxy logs, and that's it actually. And if I go back to logs, yeah, I can, yeah, those are the logs that are coming from the proxy. And here, this is the whole payload, and this is the message, complete message. And I just copy the value of that. And so, this is like, this is the whole request, like, from where it's coming. And then you get all the data about from the origin of the request, like from what virtual service, OCID of the virtual service, like start time, like the protocol use, response code. In this case, response code is 200. And you see UI, so there was the call for the UI, for example. Now, if we wait a little bit more, let me check here. I can use other logs feature like save search, and then I can search, for example, for the specific response code 503. Usually there is, yeah, okay, so this here. In this case, this is how you can, searching for the response code, you can quickly find, okay, where is the problem? And then we can see here, like that when I copy this value, I can see here that the problem is with breeds. For example, you see the user agent here. So obviously, this microservice that is calling is written because this is like Node.js library. I'm looking for the response code to see. Yeah, it's there, like response code CH503. And this is like our series. So, okay, this series, this problem. So when somebody is calling this series, you get 503. Okay, let's fix this series back. This is, for example, how I'm just scaling back. And let me just check my, yeah, so because I scaled to down, so obviously my UI performance is bad, but we fix those things here, and you see now they are approaching this 1090, and in about a minute or so, this will also look good on the UI side also. Yeah, so I think this is what I have to show you as a demo. And so my only thing that for you like that you can like I would like you to remember, it's really Service Mesh is simplified development on your cloud native application. Now think about those things that I just did a demo, and essentially you need something like that in your application. Otherwise, yeah, you can use those other libraries, but it's not easy, especially across the teams. Now, yeah, you can deploy some open source other projects that can help you in this area, but again, it puts some burden on you to maintain this. And for the end, before I let's say stop talking and open the Q&A part, I wanted just to share those resources. So so there is the documentation, there is a getting started. So, and in getting started, you can go through all the prerequisites that you need for the Service Mesh. And then there is Service Mesh tutorial, there is reference architecture. And you can actually contact me directly if you need any, if you have some question, if you need some clarification, or you want to run, POC, or maybe if you're struggling with tutorial, or maybe you want to apply Mesh on your application, not on the tutorial, and you are struggling, feel free to contact me, and we will help you with that. Yeah. So with that, I'm breaking. I'm handing over to you, Tara, back, and then we will use the rest of the time. We will use for the live Q&A.
Great. If you enjoyed today's session, we'd like to invite you to join our upcoming developer events here, and then we also have this email as well if you wanted to just reach out in general about upcoming events. And as you're exiting the Zoom, we have a 1-question survey that's just going to ask you for your feedback on today and how you enjoyed the session. So we encourage you to share with us anything about today or what you'd like to see from us going forward. I'd like to thank Dusko again for the great presentation, and thank you all for joining us here today. So with that, I'll go ahead and end today's session. Have a great day, and we hope to see you again next time.
Bye for now.